Alrighty, this last example is just showing you a situation where the two curves you're trying to find the area between intersect more than one time, all right? But the process is just the same, it's just a little bit longer, okay? So I want to go through one example here. Again, we want to create the curve here. So here's one function, here's the other. I'm going to create, and I'm just going to use shorthand here, and g of x. Okay, so this is a table so we can plot. So since we're given this, I'm just going to find starting -2, -1, so -2, -1, 0, 1, 2, 3, maybe. If we need more, we can find more, okay? So if I plug -2 into the f function here, you can take your time and do that. Pause the video and fill this table out on your own, but I'm just trying to create a table of values here. So when I plug -2 in, what you'll get out of the f function is -8. When you plug -2 into the g function, what you will get out is -8 as well. That's lucky. So that's our first point of intersection as well. -2, -8. And they both happen to hit that point there. Okay. So what I'm going to do is just fill this table out. Again, all you're doing is plugging in these x values to each of the functions and getting their y values. Okay. So you can pause the video and do it on your own while I do it here very quickly. Okay, so I'm going to plot f of x first. Okay, I've got -2, -8, -1, +6. Excuse me, 0, 0, 1, -8, 2, 0, 3, 42. So that's something way up there, right? Okay, so if I connect these dots, maybe it looks something like this. I don't know, it's not perfect, but it's something. Okay, and then I've got my other graph here, g of x. We've got -2, -8, -1, -3, 0, 0. There's another point of intersection. 1, 2, 2, 0. And there's the other one right there. 3, -3. That's somewhere right here. Okay. So if I connect these, well, this is just a parabola, so it probably looks something like that. Okay. So we've got it. Now, the area we're trying to find here is between the two curves. Now, this happens more than once. That's here, okay, and here, right? Okay, and this one goes underneath it. Now, the reason why this is different from the sine cosine example up here is because this is going to continue to repeat over and over and over again, right? So it just asks you to find area of one of them, where in this case, right, these are only intersecting these 2 times, and then they're never touching again, okay? So it's bounded and restricted just there. All right, so what we're going to do is look at this graphically. We're finding the area from here to here, and then we can find the area from here to here, right? So basically, we want to find the area from -2, right, to 0, and then from 0 to 2 separately. So the area here is going to be the integral from -2 to 0 of, again, the top function, which this function is f of x. This function down here is g of x, right? So we're finding the integral of this f of x, right, minus the g of x function, dx. That's the first area, okay? And then we're adding, right, because we want to add this other area to it, the integral from 0 now, right, all the way to 2 of, but what do you notice? Which one's the top function now, right? It's the g function. So it would be g of x minus f of x dx. Okay, so again, it's just the same idea, top function minus bottom, top minus bottom, but we have to do it twice and add them together. Okay, so if you were to substitute in these equations, you'll get f of x minus g of x. I'm going to put the negative, I'm going to distribute the negative as I go. All right, so since it's a minus and a negative here, it's going to be plus x squared minus 2x. Okay, and then g of x, this is from 0 to 2. Again, minus 3x squared cubed plus x squared plus 10x dx. Again, I'm distributing the negative as I go. These can cancel, and you can combine some stuff, so let's do that. 3x cubed, those go away. This becomes negative 12x dx plus integral from 0 to 2 of negative 3x cubed plus 12x dx, right? Okay, and then we go along about this the exact same way, okay? So I'm not going to do all this work again because it's very repetitive. You've already seen this a lot of times, but I will say once you get to the original equation, you need to be doing the fundamental theorem of calculus twice. So I'll put in those last steps here that look like this, okay? So you're integrating from 0 to 2. So what you eventually will get is f of 0 minus f of 2 Now these just look like numbers right now, but when you go through and go ahead and do that, you'll eventually get to this part where this is f of 0 minus f of negative 2 plus, right, this fundamental theorem of calculus, f of 2 minus f of 0. Okay, and your final answer when it comes down to everything should be 24. Alrighty, that's the last example. You are ready to go for the practice for 11.2.